Hello, I am Sunita. Welcome to my class. Here I am going to discuss JPSTR science topics according to the syllabus. Here the topic is thermodynamics. In that one, we will discuss about in detail heat engine, types of heat engine, refrigeration, working of refrigerator. Let us start the class. Heat engine. A heat engine is a system which converts heat into work by taking heat from the reservoir hot body to carry out some work. Then here this is the heat engine. This is the reservoir. This is the sink. Reservoir having high temperature of heat. Then sink is having low temperature of heat. Then this heat engine, it will convert some amount of heat to do useful work. Then here heat engine, it will take heat from the reservoir, then it will do some work. After completion of the work, then it will leave some waste in the form of a heat. In the system there will also be some waste in the form of a heat. Then this heat engine, after converting heat into work, then it will leave some waste in the form of a heat. There are different types of heat engine in which Carnot engine has the maximum efficiency. Then you can find different types of heat engine. In this one, Carnot engine has the maximum efficiency. Then here you have to remember, heat engine is nothing but it will convert heat into work. Then it will take heat from the reservoir, then it will do some work, then after it will leave some waste in the form of a heat. That is very important. We know that thermodynamics is the study of relationship between heat and work. Already we know thermodynamics is nothing but the study of relationship between heat and work. The first law of thermodynamics and the second law of thermodynamics helps in the operation of heat engine. Then these two laws, first and second law of thermodynamics, it will helps in the operation of heat engine or working of an heat engine. The first law is the application of conservation of energy. The first law, it is nothing but the application of conservation of energy. Conservation of energy means energy can neither be created nor be destroyed. It can convert from one form to another form. The second law sets limits on the possible efficiency of the machine. Second law, it will give the information about the efficiency of heat engine. Then next one, efficiency of the machine and determine the direction of flow of energy, and also it will gives information about the direction of flow of energy. Types of heat engine. There are mainly two types of heat engines: external combustion engine and internal combustion engine. External combustion engine, here the fuel gets burned outside the engine at a far distance from the engine, by which it can produce force and motion. In the case of an external combustion engine, the fuel, it will get burned outside the engine or at a distance far from the engine. Then after burning the fuel, it will produces a force. Because of the force, the motion of an object, it will occur. A very good example of an external combustion engine is a steam engine. External combustion engine example, steam engine. Already you know external combustion engine means the fuel, it will burns outside the engine or far from the engine. That engine we will call it as a external combustion engine. Let us discuss with an example, steam engine. Water is heated outside or far away from the system by using coal fire. Here to boil the water, we will use coal fire. With the help of a coal fire, the water, it will start boiling. When it reaches boiling point, then it will start converting into a steam, and steam produced is given to the top of the metal cylinder through pipes. Whatever the steam it is produced, then it is given to the top of the metal cylinder with the help of the pipes, through the pipes. The heat is given to the engine. Later this heat is given to the engine. It moves the piston back and forth. The work is done. Because of the heat, the engine, it will start working. Then the piston, it will move back and forth. Then the work, it should be done. The fluid is then cooled and compressed and reused. Whatever the fluid we will use, that you can cool, then compress, then you can reuse that same fluid. This is the working of steam engine. Internal combustion engine. Here the fuel are burned inside the chamber. Name itself it is indicating internal means inside the engine the fuel it will burn. Then car engine, a very good example of this type of combustion engine. The heat produced due to combustion is given to the engine and the work is done. Whatever may be the heat produced by the burning of fuel due to combustion is given to the engine, then the engine it will start working. It is also called as a four stroke because it takes four stroke for the piston. It will takes four stroke for the piston to complete one combustion cycle. So if we consider two types of heat engine, internal combustion engine are more efficient than external combustion engine, because internal combustion engine the burning of fuel it will takes place inside the engine only. Then here whatever the heat released it will not get wasted, it will transfer inside the engine only. Then in the case of external combustion engine, the fuel it will burns outside the engine or far from the engine. Then after burning the fuel, it will generate the heat. That heat you have to transfer from outside the engine to the engine. Then when the transferring takes place, you will waste some of the heat energy. This is because no energy is wasted in an internal combustion engine, as I told, by transferring heat from the boiler to the cylinder as an external combustion engine. But in the case of an external combustion engine, the heat you have to transfer from boiler to the cylinder. When you are transferring, it will lose some amount of the heat. Everything happens in one place. But in the case of an internal combustion engine, all the work it will happen in the one place. Engine itself, the burning of fuel and generation of the heat, transformation, everything it will happen in one place, that is inside the engine. Therefore internal combustion engines are more efficient than external combustion engine. Heat engine efficiency. The efficiency is the fraction of heat input at high temperature changes to work. When it is combustion takes place, then it will produce a heat. Because of this heat, how much work should be done, that is given by efficiency of heat engine. In the second law of thermodynamics, it says that no engine is 100% efficient. Efficiency is given by work done divided by heat input. This formula you have to remember. Then work done it will be equal to Q1 minus Q2 change of heat. Then heat input it will be Q1. Substitute in the formula of efficiency, it is given by W divided by Q1. Then Q1 minus Q2 divided by Q1. Divide these two by Q1. Then Q1 by Q1 it will get cancelled. You will get 1 minus Q2 by Q1. This is the efficiency of heat engine. Difference between petrol and diesel engine. The primary difference between petrol and diesel engine is that petrol engine works on the principle of Otto cycle. Petrol engine works on the principle of Otto cycle, whereas diesel engine works on the principle of diesel cycle. Other difference can be attributed to their structure, types and uses of these engine. Other differentiate you can do based on the structure, types and uses of these engine. The main parameters they are classified on is the type of fuel they use. One more classification of engines will be depends upon the type of fuel they will use. Generally engine run on the principle of heat transfer. Normally you know the engine it will be run on the principle of heat transfer, because engine it will work on the principle of heat transfer only. Petrol engine are internal combustion engine which have spark ignition. Petrol engine it will work on the principle of internal combustion engine. Internal combustion engine is nothing but burning of fuel it will takes place inside the engine. Then here petrol engine it have a spark ignition. Here you can see it contains a spark ignition. They run on relatively volatile fuel such as petrol. Then this petrol engine, it will works on a fuel like volatile fuel. Volatile fuel is nothing but the fuel, it will start evaporating at room temperature. Example, petrol. If you open the petrol at a room temperature, if you open petrol, otherwise if you expose the petrol to air at a room temperature, then the petrol, it will start evaporating. Second one, in this engine, air and fuel are generally mixed post compression. Before the compression, in this petrol engine, you have to mix fuel with air, then before the post compression. Petrol engine works on Otto cycle, which consists of two isochoric process and two isentropic process. Petrol engine, it will works on the principle of Otto cycle. Then it consists of two isochoric process. Isochoric process is nothing but the process, if there will be a change in temperature and pressure, that the volume of the system, it will be remain constant. Isochoric process means the process, it will occur at constant volume. If you observe any changes in temperature, pressure also, the volume of the system, it will not change. Then isentropic process means the process is as adiabatic and also reversible. In petrol engine, air and petrol are usually mixed in a carburetor before being introduced to the cylinder. Already we told, before post compression we have to mix air and petrol. You have to mix inside a carburetor before being introduced into the cylinder. Once the air and petrol are compressed, the fuel is ignited via an electric spark. Once the air and petrol are compressed, then you can ignite with the help of a spark plug or electric plug. Once you ignite with the help of a spark plug or electric plug, then the petrol inside the cylinder, it will start burning. Because of the petrol burning, then it will produce a heat. Then the piston, it will consume the heat. Then the piston, it will start moving. Then this piston is connected to a engine casing with the help of a connecting rod. When the piston start moving, then this engine also, it will start working. Therefore, in this way, the engine, it will do some amount of work. This is the working of a petrol engine. Let us discuss in detail about diesel engine. The diesel engine is also an internal combustion engine. This one we will call it as an internal combustion engine because the combustion of fuel, it will take place inside the engine, which is also known as the compression ignition engine, because here you can observe the compression of air, it will take place at higher temperature. It is named after Rudolf Diesel. In this engine, the fuel is injected into a combustion chamber. Then here, these are the combustion chamber. The fuel, it is injected into a combustion chamber and then ignited by the high temperature of the air in the chamber. Already the chamber, it contains a air at high temperature. When the fuel, when it will enter into the chamber, once it contact with the air at higher temperature, then it start immediately ignited. The high temperature of the air in the cylinder is due to adiabatic compression. Here, already I told the chamber, it contains high temperature of the air. This is because of the process of adiabatic compression. In the process of adiabatic compression, no heat, it will enter the system, no heat will leave the system. Here in this chamber, no heat, it will enter into the chamber, no heat it will leave the chamber. Therefore, this one we will call it as a adiabatic compression. Because of the adiabatic compression, this cylinder, it contains air at a higher temperature. This engine only compress the air, not the fuel. This is very, very important. This engine, it will compress only the air, it will not compress the fuel. When injected into the combustion chamber, the diesel fuel undergoes spontaneous ignition. Spontaneous means the diesel itself, it start igniting. When it is injected to a combustion chamber, when the diesel is injected, otherwise introduced into a combustion chamber, the diesel fuel undergoes spontaneous ignition. Spontaneous means the diesel itself, it will start ignition. Spontaneous is nothing but a immediate or itself, it will start igniting. This engine works on diesel cycle. This engine, it will works on the principle of diesel cycle, which consists of a constant pressure process. The diesel cycle, it consists of a constant pressure process, constant volume process, and two isentropic process. Isentropic process means the process is adiabatic and also reversible. That one we will call it as a isentropic process. Then here, this is the detailed explanation of working of diesel engine. Let us discuss the difference between petrol and diesel engine. First one, diesel engine. This engine works on the diesel cycle. Diesel engine, it will work on the principle of diesel cycle, whereas petrol engine works on the Otto cycle. Then diesel engine, the fuel is mixed with air inside the cylinder. Here mixing of fuel with air, it will take place inside the cylinder in the case of a diesel engine. In the case of a petrol engine, air and fuel are mixed in a carburetor. In the case of a diesel engine, ignition is achieved with the help of hot and compressed air. Here ignition is achieved with the help of hot and compressed air. In the case of a petrol engine, fuel is ignited with an electric spark. Then diesel engine has high compression ratio. Petrol engine has relatively low compression ratio. Here diesel engine, the compression ratio, it will be more. In the case of a petrol engine, compression ratio, it will be low. Diesel engine, high power production, it will produce high power production. Petrol engine, relatively low amount of power are produced in a petrol engine. Next difference, diesel engine works with fuels that have low volatilities. Volatile means any fuel, if you expose to air, then it will start evaporating at room temperature. But in the case of a diesel, if you expose the diesel to air, then it will not immediately, it will not start evaporating. Otherwise, evaporating rate, it will be less. Therefore, diesel engine works with fuels that have low volatilities. But in the case of a petrol engine, highly volatile fuels are used in these internal combustion engine. Petrol is a highly volatile compound. If you expose petrol to air, then it will start evaporating at room temperature. Therefore, petrol is a highly volatile fuel. Then diesel engine, generally used in heavy vehicles such as trucks and buses. Diesel engine, otherwise diesel, we will used in heavy vehicles such as trucks and buses. Petrol engine used in light vehicles such as motorcycle and also cars. Diesel engine, relatively low fuel consumption. In the case of a diesel engine, consumption of fuel, it will be less. In the case of a petrol engine, high fuel consumption. The petrol engine, it will consume more amount of fuel. Diesel engine, high initial and maintenance cost. This maintaining of diesel engine, it will be very cost. High initial and maintenance cost, it will be more in the case of a diesel engine. Petrol engine, comparatively low initial cost and maintenance cost. Normally, petrol engine you can maintain at low cost maintenance. Refrigeration, heat and cold are two different entities associated with temperature. When the temperature is less, our body, it will feel cold. When the temperature is more, our body, it will feel hot. Body temperature is measured by a thermometer. Thermometer is a device used to measure a body temperature. We prefer to wear light colored cotton cloth when it is hot. This light colored cotton cloth, whatever the light rays falls on the cloth, they will get reflected, and also this cloth, it will absorb less amount of heat. As it is absorbing less amount of heat, even though it is hot outside, our body, it will feel little cold. We prefer to wear dark colored polyester cloth when it is cold as per the weather. Dark color polyester cloth, it will absorb whatever may be the light rays falls on the cloth. Even it will absorb more amount of heat. Because of the absorption of more amount of heat and light, our body it will feel little hot even though the atmosphere is cold. Heating is the process of keeping the heat in the body. Heating is nothing but you are providing heat to a body continuously. You are providing heat to a particular body. Refrigeration is the process of cooling space. Refrigeration is nothing but you have to make the particular object or particular atmosphere cooling effect. You have to give a cooling effect. That process we will call it as a refrigeration. Refrigeration involves the process of removing heat from a body. Then how you will achieve refrigeration means, this is the process. It will remove excess of heat from your body and cooling it to a lower temperature than the actual. Then it will give a cooling effect, lower the temperature than the actual. Then refrigerators are used for the refrigeration process. Normally we will use a refrigerator in our home to feel a cooling effect. The process we will call it as a refrigeration process. Refrigeration process is nothing but you are providing cooling effect to a particular object. How you will do that one? If you will remove excess of heat present in the body, then you will cool the body at a particular temperature. Then that process we will call it as a refrigeration process. We will use refrigerator to cool some of the objects in our home. Working principle of refrigerator. Refrigerator work on the second law of thermodynamics. Working principle of refrigerator, it will work on the principle of second law of thermodynamics. In this process of refrigeration, unwanted heat is taken from one place and discharged into the another. Whatever may be the unwanted heat, it is present in one place, it is removed, otherwise it will discharge into the another place. The common refrigerator which we have in our home work on the principle of evaporation. In our home we are using a refrigerator, then that refrigerator it will work on the principle of evaporation. A refrigerant is a substance used in a heat cycle to transfer heat from one area and remove it to the another. Refrigerant is nothing but a working fluid. This we will use in a heat cycle, then it will absorb extra amount of heat present in one area, then it will remove it to the another. A refrigerant when passes through the food kept in the refrigerator. Normally we will use a refrigerant in a refrigerator, then this refrigerant it will passes through the food kept in the refrigerator, then it will absorb heat from these items. It will absorb extra amount of heat present in the food items, then transfer the absorbed heat to the surrounding. Whatever may be the heat it will absorb from the food, then it will transfer the absorbed heat to the surrounding with a less temperature. Then here in our home, to keep the food for a certain days, otherwise for a certain hours, we will use refrigerator. Then in the refrigerator we are having a refrigerant, then this refrigerant it will absorb extra amount of heat present in the food items to make the food items cool. Then the food items when they are at cooling temperature, when they are having less temperature, then the food items you can preserve for a longer time. It will not get destroyed, easily you can preserve. The component of refrigerator. This diagram it will represent single stage vapor compression refrigerator. There are four components in the refrigerator system. They are evaporator. This one is the evaporator. Second one compressor. Third one condenser. This is the condenser. Fourth one is expansion valve. This is the expansion valve. Let us discuss the component of refrigerator. This diagram it will represent single stage vapor compression refrigeration. First one is evaporator. It is the main part of the refrigerator. Evaporator. This is the evaporator. This is the main part of the refrigerator that helps to keep the device and things cool always. It will make the device means refrigerator, The evaporator, it will make the refrigerator always cool. Then whatever may be the food items, otherwise other things you kept in the refrigerator, it will maintains at proper temperature, otherwise it will make it cool. It features the tube with high thermal conductivity. It contains a tube. Then this tube, it will possess high thermal conductivity. It will absorb high temperature of heat that helps in absorbing the heat rejected by the fan or coil in the system. Then inside the refrigerator you can see fan or coil. With the help of this fan or coil, the excess amount of heat it will be rejected. After rejecting excess amount of heat, this vapor, it contains a tube. Then that tubes, it will absorb excess amount of heat present inside the refrigerator. Then with this evaporator, it will gives the cooling effect of the refrigerator. Otherwise it will maintain a lower temperature of the refrigerator. Therefore whatever the items you kept in the refrigerator, it will not get spoiled. It will maintain at lower temperature. Compressor, it compresses the low pressure, low temperature vapor into a high temperature, high pressure vapor. The refrigerant is passed from the evaporator. The refrigerant, it will pass from the evaporator, is compressed in a cylinder. Later it will compressed in a cylinder to generate high temperature, high pressure gas. The main function of compressor is to generate high temperature and high pressure gas. Then here with the help of this compressor, the refrigerant, it will be evenly spread out throughout the refrigerator. Then it will make the refrigerator to feel cool and it will maintain the temperature of the refrigerator. Next one, expansion valve. This is the expansion valve, helps to control the flow of refrigerant into the evaporator or cooling coil. You know, refrigerant, it will makes the refrigerator to cool, otherwise it will maintain the temperature of the refrigerator. Then this expansion valve, it will control the flow of refrigerant into the evaporator or cooling coil. Expansion valve is also known as a flow control valve, because it will control the flow of refrigerant in a refrigerator. It is a sensitive small device that aids to sense the temperature change of the refrigerant. Also, it is a very sensitive small device. It will sense the change in temperature of the refrigerator. Then it will maintain the flow of refrigerant. This part is the condenser. It is situated in the back side of the refrigerator. It comprises a set of tubes with external fins. It contains a set of tubes with external fins placed back of the refrigerator. This components helps to convert gaseous refrigerant into a liquid form. This condenser, it will help to convert gaseous refrigerant into liquid refrigerant, liquid form of refrigerant. Working of the refrigerator. Vapor compression refrigeration cycle is followed for the refrigeration process. In this process, the evaporator, compressor, condenser and expansion valves are connected to the tubes made up of copper and steel. Here, this diagram, it will represent a single stage vapor compression refrigeration. Here it contains evaporator, condenser, expansion valve and also compressor. These, they are connected with the help of a tubes. Then this tube is made up of a copper or steel. Working of the refrigerator. Evaporator tube is placed throughout the refrigerator. Here you can observe the evaporator tube is placed throughout the refrigerator. When heat is absorbed, the liquid refrigerant absorb the heat, then convert into vapor. Then already you know, inside the refrigerator, if you are having excess amount of heat, that excess amount of heat is absorbed by the liquid refrigerant. Then it will convert into a vapor state. Then heat absorbed is passed through the external environment through compressor from vapor state to liquid state. Then the liquid refrigerant, it will absorb the heat, then it will convert it into a vapor state. Then the vapor state, when it comes in contact with the external environment through with the help of the compressor. Again it will convert from vapor state to liquid state. Then this process it will repeats when heat is absorbed and passed through a expansion valve to the evaporator. This conversion of liquid refrigerant to vapor, then vapor to liquid, then this process it will repeat. When this heat absorbed, then it will passes through the expansion valve, then it will reaches a evaporator. This process helps to keep the refrigerator cool always. Then because of this process, the refrigerator it always stays cool. It always becomes cool. Thanks for listening my class. Send me your valuable feedback.